There is a purpose of that, because the purpose of this proposal is they want to have a license that doesn't give them any problems when they start. They want to have a very, very soft license. They want to have a very, very low value. And we can come back to that because we can compare this proposal with the so-called target dilutions of other Australian desalination plants. Shown here, a table, and this is what they call target dilution, and it's all based on 100 meters. Perth, 45 to 1. Sydney, you can read these numbers. Port Stenbeck, they still promise a 50 to 1. Point Lowly, 11 to 1. They allow the highest concentration of pollutants. And this is in the most sensitive area in Australian waters. This is shocking to me. It should be to you. Yeah? And what you can say is the proposed discharge will cause substantially more marine pollution than any other Australian development, just on the basis of these, because these plants, they all work on the same way and they release the same sort of pollutants. This one goes for the softest license from the start. Now just another little thing is, in Perth they started with, they want to achieve 45 to 1. They did some measurements and they adjusted it to 20 to 1. Oh, so they approved it, they started, they did some measurements, and what they observed is shown on the next slide. This is what they observed. So just to give you an idea of what we are talking about, this is Coburn Sound. What's shown here is in Coburn Sound measurements. It's very difficult to see here, but basically they did measurements from surface to bottom along these black dots. And the red dot is the desalination outfall, and this is what you measure in terms of salinity from the surface to the bottom. Running along these sections, this is the desalination outfall, and the distance is shown here. So this is 1 kilometer, 2 kilometers, 3, 4, 5 kilometers. There is a signal in terms of salinity. Here are the values. Blue means background, and red and yellow and red are elevated salinity near the bottom. This is where the outfall is. And you can see the signature of the desalination plant over a distance of 2 kilometers. This is the dissolved oxygen saturation, how much oxygen is dissolved. And yellow is sort of just below 80, is sort of background, and you can see that the oxygen content is reduced near the bottom, over 2 kilometers. And if you read a little bit about conditions that they have in their license at the moment is, in the license for the Perth desalination plant says they have to do something if the dissolved oxygen content drops below 60%. The operators want to have that detail of the license removed. For 1.5 years or so they tried to change the license so that they don't have to worry about these tiny little things anymore. These are so-called brine underflows. If the oxygen concentration drops further, it can kill. It can have disastrous effects on bottom-dwelling marine organisms like cuttlefish, like prawns, and you can see it can take place. We don't know whether it happens, but it's likely to happen, in particular because we have the Dodge tides. This is just a little bit background because often the Perth desalination project is used as a, what's the word now? I'm just missing the word. As a showcase. Yeah, look at this, it all works fine. And that's all published information. So, going to the next, there will be a couple. And you can also, if you have a little bit of knowledge of how to work out dilutions, all you need to do to derive dilutions is to measure salinity. You go out with a boat, you have good equipment, you measure salinity, and you can do that. Yeah, fairly easy. Okay. This is where do we have to point? I pointed you, and then it doesn't change. Ah, there was I have included some fascinating effects here. And I went to a meeting recently with the prawn industries, and I really pronounced this as you write it, because I'm from German. And they said, Coburn, Twitter. But even that day I didn't get it. But just half a week later, I thought about it, and I said, oh, now I understand. Who could even make up this name for this? That's not how you write it. That's when you're from Germany. You know, it's just a bad start. Little bit text. You can think about just. I'm not one of the scientists who say you need to do more measurements. Scientists usually say we need to do more measurements. We need to do it because scientists live from funding that they can do their research. No, we don't need to. Just to mention this, it's all critical. It's based on salinity. Salinity is very important. If you look at the instruments that they use, they're all unsuitable. You know, because they use instruments which are probably $500 or so. They don't have the required precision. Yeah, the precision is in a range which already starts to harm the cuttlefish. That's the precision, just the chance of what you read. There's only a few measurements taken in the vicinity of the seafloor. We want to know, I should speak into the microphone. Do I have to repeat the last 15 minutes? I mean, there is a gap of measurements. What we are interested in is what happens directly at the seabed. You know, because they discharge brine near the seafloor. It's important how strong is the flow there, not how strong is the flow at the surface. Yeah. But as I said before, we have enough evidence demonstrating that Upper Spencer Gulf is most unsuitable for this project. Yeah. There's no more measurements required. And I'm building up to come to the highlight of this presentation. Because it's about these sweet neighbors here. And it's about the plan to discharge the toxic brine within, say, 500, 600 meters from the cuttlefish aggregation. And one of the key statements or key claims of BHP Billiton is the return water would not affect the Australian giant cuttlefish because the zone of ecological effect, and the breeding habitat would never overlap. And I say it again, like it's written there, would never overlap, and to make it really clear, would never overlap. Never. That's really, really, that's a big promise, isn't it? Never. Really never? I did some background research. Yeah, because I am a scientist, I'm curious. If someone tells me it never happens, I say, well, no, maybe it can.